Hi and welcome to Geeks for Geeks. Today we would be discussing yesterday's problem of the day, that is matrix operation. This problem appeared in Samsung and this is an easy level problem with a success percentage of 79%. Okay, before we start, let us wait for just 10 to 15 seconds so that just everyone joins and I can just turn on my preview screen. Operation. Fair enough. So please like the video if possible, because we have some people watching at the moment. Okay, fair enough. So let's start and read the problem statement. We are given a binary matrix of dimension m into n. So binary matrix, binary string, it means that the element consisting would be of 0 or 1. Only two types of elements. Okay, fair enough. One can perform the given operation in the matrix. So very good evening, Gagan. So you need to perform some operation on the matrix. So if the value of the matrix I and j is equals to 0, then we need to continue in the same direction and check for the next value. What do we mean by this? Suppose we are coming down in the matrix and then we encountered a 0. If it is a 0, then we would keep moving down. If we are moving on the right and we are encountering a 0, then we would keep moving right. Okay. Now moving forward, we are said that if matrix I and j is equals to 1, what do we mean? Okay, so 0 is sorted now. 1 means we need to update I and j to 0. First we need to update I and j to 0. So let us write after this. So if 1, then we need to convert it to 0. Okay, then the first thing, then let me just delete this. Okay, delete this page. Okay, fair enough. So let's proceed. Yeah, now we are said that update the matrix and change the current direction from up to right. Okay, so if you are moving up, you need to go to right. Okay, you need to change your direction from right to down. Okay, so if you are moving on the right, you need to go on the down. Okay, and if you are moving down, you need to go left. So if you are moving down, you need to go left. You need to change your direction. And if you are moving left, you need to go up. So if you are moving left, you need to go up. This is what you need to do. So what are the steps we have written? If it is 0, then we need to continue. If it is 1, then we first need to convert it to 0, and then we need to convert u to r, r to d, d to l and l to u. This is what you need to do. Moving forward, initially you start from the cell 0, 0. Okay, so you have said the starting point is the 0th point. Okay, top left corner. Okay, and then you need to move in the right hand direction. You need to move on this side. The task is to find the first cell which leads the matrix outside. Okay, so you would be given a set of instruction. Suppose there are 0, 0 and 0. Okay, suppose this is the matrix. So you would start at this point, then you would keep moving this side, then you would keep moving this side. Okay, the first cell, okay, this is the first cell which is leading me to outside the matrix. So we would say that this address is our address. Now the next thing to note here is that we don't need to consider about 1 indexing. Everything is 0 indexing here. Okay, we know that, still I am mentioning it so that I don't create any further confusions. Moving forward, let us first see. So we would be at this position. Okay, then we need to move on the right hand side because it is 0. We need to continue moving. So we would move on the right hand side. This is the right hand side, and at this point it is r. Okay, so r is to be converted to down. Okay, so r would be updated to down and we would go the next move to down. Okay, then this is 0, so we need to continue moving down. When we would continue moving down, we are coming to the point where we are outside the matrix. And which address led me to outside the matrix? This address. So what is the address here? 0001. Okay, 1011. That is why the answer to this is 11. Fair enough. I hope things are pretty clear. But this is a kind of implementation problem. Why I am calling it an implementation problem, and when a problem is called as an implementation problem? Because you just need to do what is said. Okay. What you can do is, you are given the matrix. See, you are given the matrix. Then you need to traverse the matrix. So given the matrix and you need to traverse the matrix. So that would be m cross n, traversing the matrix. And checking the condition would be just handled by a if else statement. So that would be a constant operation. So the time complexity of this, even before implementing, we can confirm that it is a time complexity of m cross n. Okay, and it is feasible enough. So we would be moving ahead with that approach without any further ado. So now, before moving forward, there are some things to be told. Okay, so the first thing that we need to do is, when do we know that we are outside the boundary? Okay, we are outside the boundary. When the current index is less than 0, when I is less than 0. Suppose we have I and we have j. So suppose if I is less than 0, okay, suppose it is -1 and j is 0, then this is not valid. So I would be less than 0. Same goes for j. J is less than 0. Now suppose the size is n cross n for simplicity. So if the index is greater than n minus 1, okay, then it is also not possible. Okay, fair enough, because zero indexing, the indexing can only go till n minus 1. So I should be less than n and j should be also less than n. Okay, and if this is the condition, so you can write that I should be greater than -1, j should also be greater than -1. If these two conditions are fulfilled, that means we are within the boundary. If any of this condition revolves to the false value, that means we are outside the boundary. So what we can do is, we can have a function check where we would provide the m and n, okay, and I and j. This is the current index. So if any of this goes to true, then we would return true. Okay, that is, we are outside the boundary. Else we would just return false. Okay, fair enough. Now we would continue moving in the same direction as it is told. But before that, we first take out the size m and n. Then we are starting with I is equals to 0 and j is equals to 0. And currently the direction is the right hand side direction because it is told enough. Now we would keep moving forward till we are within the boundary, we would keep doing that. Now the current n and I is I and j. Then if the current is 0, then we need to keep moving forward. So if the direction is r, suppose this is 0 0, okay, and the previous direction is r and currently the value is 0, so we need to move on this side. So this is 0 0, this is 0 1. That means that this j is incremented. That is why j is incremented here. Now suppose we need to go down. If we are going down, the indexes, this is getting incremented. This is what I, that is why it is I plus plus. Same goes for left. If we are moving in the right direction, the left direction would decremented value, that is j minus minus. If we are moving on the up, that would decremented value, that is it. Now if the value is equal to 1, first we need to make it to 0. We are making it to 0. Then moving forward, if the direction is r, we are making it first d. Okay, direction would be d. Now direction is d. So if the direction is r, then we need to convert it to d. This is what we are doing. Direction is being converted to d. Then if it is d, is the direction would be equal to l. Okay, and we are not moving forward, then we would again come to this. Okay, then I, j, n and m, it would if at any point we get outside the boundary, okay, we need to quickly say that index only, because पहला जहाँ पर मिला वही report कर दो. Okay, this is what we need to do. This is what we are doing. The first point where we are getting the true value, we are returning that. Okay. If it was asked that tell me the last value where we were getting outside the boundary, okay, and this question is to be modified a little bit, okay, because this, for this scenario, this is not feasible, but still I'm telling you, okay, what we would do is instead of returning, we would keep updating the answer, and after all the traversals are done, we would say that this is the last updated answer. Okay, this is what we would do. Okay, I hope things are pretty clear with you. Still, I would wait for the next 30 seconds to see if there is any doubts or not. If there are no doubts that is persisting in your head, then we would turn off the session. Okay, let me start the timer for 30 seconds. By the way, just a small bit of information. Today, we have a most asked DSA session at GFG main channel, which would be taken by me. Okay, so if you are free and if you are seeing the video before this timeline, consider just having a look at that. If you like, you can proceed forward. Okay, that's it for today. I see no doubts popping in. Thank you and have a nice day. All the best.